Hello, everyone. How are you? I hope you all are doing great. And thank you for showing your love and appreciation to the videos. I've received so many DMs, so many texts on my WhatsApp stating that these videos has helped your organic revision way easy. Many of you have texted that organic was feeling like a daunting for you, and now it's like you're eating a cheesy cake. So thank you. It's really meaning a lot to me that yes, we are working on it and it's working for you as well. It really means a lot. So thank you for all your love and appreciation you have given to me. Please keep supporting in the same manner. Now, today we are going to do out with oxidation and reduction and a good news. But in fact, I should say that it is no more a good news for you now because now I have received text saying Mechanics is so very scoring. Organic is so very scoring. It's a $1 million thing now. Listening from all this from you all, that once the thing which feels like a feast for you has now become an easy cakewalk for you, and I'm happy and overwhelmed to see that I'm able to make a meaningful contribution in your acads. So when it comes to which organic oxidation and reduction, you don't have a mechanism anymore. You just have a reaction. So since there is a lot more content, we'll cover out multiple small things that actually counts and make you hit that perfect 7 and a perfect score when it comes to that organic session. I will also, in this video, will also discuss about areas that students are actually putting out their efforts, which they should not, because I have received multiple queries. Can this type of question be a part of examination? Can this type of question be a part of examination? So we'll cover up with that also, that what is there, what should be required, because at this time, along with the hard work, what is more required is a strategic work, right? So we cannot put our efforts in doing something which is not going to give you, which is not going to be examined or being tested. So it's good. We should be doing that, but let's pause it for now and let's focus on what is being asked, because you all are very wondering, many of you, that we should do this, we should do this, or we should not do this. So we will definitely discuss that as well. So please believe me when I say we cannot afford skipping it or seeing it in parts or missing out something from it. So be tuned, see it entirely, and I'm sure we are going to unlock something awe moment for you, or you will say, okay, that's nice, that's good, that's the point to be noted. I sure we are going to move that. So let's start with oxidation and reduction. So first we'll talk about oxidation reaction. Now, the word itself says oxidation. Okay. Now, this oxidation could be a part interlinked with electron transfer reactions also. So I hope we all know that when we have to clarify anything that this is oxidation, we don't write down stating that it is the loss of hydrogen, gain of oxygen, something like that. No, please claim it stating with the oxidation number, that the oxidation number changes from +1 to +2, hence an oxidation number is there or oxidation is happening, right? So increase in oxidation number leads to oxidation, right? Okay. And if you have not, if you are having any query with that, finding out the oxidation number, don't worry. After this, we'll start out with the pH and the electron transfer. So we will be covering all this over there as well. So yeah, in this particular case of oxidation, when it comes to organic, we'll talk about the oxidation of alcohols. Now, if you remember, we have three types of alcohols. You have primary alcohol, you have secondary alcohol, and you have tertiary alcohol, right? So when you talk about a primary alcohol, it get oxidized to aldehyde, which further get oxidized to carboxylic acid. Okay. In the case of secondary alcohol, it oxidizes to ketone and there is no further oxidation of that. And tertiary alcohols, they do not get oxidized, right? Now, when a primary is getting converted to aldehyde or aldehyde is getting converted to carboxylic acid, or over here, what is required is the oxidizing agent. Now, what are the oxidizing agents? There are two oxidizing agents. One is KMnO₄, one is K₂Cr₂O₄. You can learn any one of them. It works, but I will prefer go for this K₂Cr₂O₄. Now, let me tell you the reason for that. O7. Now, why? Because many a times questions have been asked. You have been given with three different alcohols. Identify whether the given alcohol will be able to get oxidized or not. So in that, K₂Cr₂O₄ works. How it works? It is originally orange of color. So if you pour it in an alcohol which will get oxidized, will go green in color. So if that oxidation is happening, you can do the same for KMnO₄ also. It changes its color from purple. So this is something which is orange green, which is mostly there in the MS and all. So I will prefer to go for this particular thing. So what is K₂Cr₂O₄ doing for you? It also helps you to identify the alcohol plus working you as an oxidizing agent. So one reagent gives us two solutions. So why not stick to that, right? So we'll say that its original color is orange. If it gets converted to green, that means it is an alcohol which will go oxidation. That means it could be a primary or it could be secondary. If there is no change, that means the alcohol was a tertiary alcohol. I hope this is clear to you. Perfect. Now, 1%, if the question asks why tertiary alcohol do not undergo oxidation. So tertiary means my carbon is like this. CH3, CH3, or there could be any other alkyl group also, right? And this is OH. So to carbon to which my OH is attached is not having any hydrogen to further oxidize. This is known as it is having the absence of alpha hydrogen. And that's why it will not undergo oxidation. Correct? Whereas that means primary and secondary will have that, right? Okay. So first thing, we will use an oxidizing agent, K₂Cr₂O₄. Any oxidation is happening, we'll stick to that particular thing. Easy? Perfect. Next thing, this oxidizing agent needs to be acidified. Now, when I say acidified, that means we are adding it into an acidified medium. It could be H2SO4 or any acid. So we write down the agent as acidified K₂Cr₂O₄. Perfect. One thing sorted. Now, if the question says, second thing, one more thing, we need to heat the solution. So in condition, we'll write down heat. Right now, along with heat, listen one thing. Over here, for a primary alcohol to aldehyde, you will, if the question says, I want just aldehyde to happen and I don't want that oxidation to further get continued for carboxylic acid. So we will say we will do an reaction under the presence of acidified K₂Cr₂O₄, which is oxidizing agent. And we will heat the solution, and along with that, we will distill it. That means basically we are doing distillation. So once you do the distillation, reaction stops then and there itself, right? First thing first. Next, if the question says, don't want aldehyde to form in between, instead you want your alcohol to directly get converted to carboxylic acid, you'll use same thing, acidified K₂Cr₂O₄, heat it, but now you will reflux it. Please store these two words into your mind. For carboxylic acid, use the word reflux. If you want to stop at aldehyde, it's distillation. right? If you are not doing distillation, that means your reaction will go complete. It will form aldehyde, and then that aldehyde will get converted to carboxylic acid. Am I clear with that? Anything, any questions, any doubts? Secondary to will directly convert to ketone. So you need not to undergo any separation thing or prior thing for that. It's also, it will not undergo anything further. So it will stop at ketone only, right? Any questions, any doubts up to here for this oxidation? Perfect. Now, from here, the question can come, they can ask you about the functional group. The question comes in the functional group. Now they ask you, okay, this is forming. Now, the second thing they can interlink and then they can ask is the functional group of the compound. So what does the mess we create over here is, when they ask you the functional group, let's say they ask you the functional group of aldehyde, we write down aldehyde. For carboxylic acid, we end up writing down carboxylic acid. For alcohol, like we write down alcohol. No, these are not functional group. That's a class of compound. That's a homologous series basically. It's a series. It's a class of compound. That's not a functional group. So for alcohol, your functional group is hydroxyl. Please don't forget it. It's hydroxyl. For aldehyde or ketone, since they have C double bond O group only present, so they are basically called as carbonyl. For carboxylic acid, you will use, since it has C double bond O, OH, it will be carboxyl, right? Please keep it. They ask you for these. Mainly, they ask you for these. You know what? IB is very sharp, right? We'll admit that, right? Because they're same. Now, ether has a functional group, ether. Ester has ester. So while they will ask you the same thing, they ask you this. This is different from what is the actual function of the class of the compound. Plus, listens and thinks smartly. When we have a question paper, we have a paper linked, questions linked from one part to another part, right? We don't have a question one, 4 parts, that's it, it's done. Next question has nothing to do with that. No, we have a long questions which has interlinked part to it, right? So if they're asking you something in the first part, it has for sure the link in the second part, right? And when it comes to the compounds, you think it of your own that the same thing applies for IUPAC also. So when you start naming out the compounds, I have students texting out that very complex compounds of the organic, and they ask me the name of these compounds, that ma'am, what could be the name of this organic compound, what could be the name of the organic compound. So what I do is I just write down the answer below to it, and after that I just state over there, this is the answer, but that's not required for you. Now, why it is not required? Think smartly. If question is asked me, if I had a compound, in that particular compound, I have halogen also attached to it, let's say carboxylic acid also attached to it, let's say nitro group also attached to it, multiple functional groups have been attached to it, will it be further get utilized in the next subpart? No. And I hope you all have done the quite more amount of past papers. Have you ever seen it? What is the trend? They give you a functional group, name, IUPAC naming. They ask you the name and they have further linked part to it. It could be a secondary alcohol, primary alcohol, secondary halogenoalkane, primary halogenoalkane. They could ask you write down the name of any structural isomers. That is doable. Something which has linked from some previous part. Right? So please understand, we know we should know the IUPAC naming, but we don't have to do out for multiple compounds coming out in one single go. Yes. So please, many a times just hard work doesn't work. We need to be very smart also by doing that. So do that, okay? And don't break your head in doing something which is not going to be assessed in next How many days? I think 30 days almost. Okay. So I hope this is clear, right? And we are going to retain to this. So alcohol functional group is hydroxyl. Carbonyl is for aldehyde and ketone. And carboxyl is for carboxylic acid, right? Perfect. Benzene you will call as aromatic ring. Clear? So you could have taken an example of any alcohol. Let me take an example of the alcohols for you. So let's say CH3, CH2OH. That's a primary alcohol. Will get converted to form CH3CHO, which is ethanol, which further oxidizes to form ethanoic acid, right? Conditions. If I have to go from here, I will say acidified K₂Cr₂O₇ plus heat. Over here, I will say acidified K₂Cr₂O₇ plus heat plus reflux. Okay, if the question says stop here only, don't go further, I will say for here, I will add distillation, right? Let's say I have a compound CH3CH. It is going to form CH3, C double bond O, C2H5, right? And it will be again acidified K₂Cr₂O₇ plus heat, right? Clear. Now, if you have to start naming also all this compound, so this is ethanol. This becomes ethanol. This becomes ethanoic acid, right? This will be 1, 2, 3, 4. Butane to ol is going to form me butane to one, right? Clear? Any questions, any doubts? Okay. Now, when the examiner gives you the question, there is a possibility he write down O like this. That's basically showing you an oxidizing agent, right? So that means the examiner or the question is doing oxidation reaction only. So you have to go accordingly. Can you use this nascent oxygen, this type of oxygen instead of this? No. You write down the reagents very clearly, very patiently. Many times they just ask you the reagents and the conditions. So we have to stick to that. Clear? Now, coming to the reduction portion. So when you talk about reduction, you are going back, right? So you have carboxylic acid. It will get converted to aldehyde. And this aldehyde will further go alcohol. Or you can say you have ketone, which further get converted to secondary alcohol. Like you can use in bracket O for oxidizing, in bracket H will act as a reducing agent. But actually, what is the reducing agent? We will the reducing agent you will use. Reducing agents are again two. LiAlH₄ and NaBH₄. You can use any, but again, I will give you a preference over here, this. Why? This is strong. So if you have to reduce carboxylic acid, this will not work. NaBH₄ will not work. So why to remember to, right? So let's stick to LiAlH₄. It will reduce everything. Clear? Any questions, any doubts? So that means if I will go back to this, ethanoic acid will give you ethanol, which further gives you ethanol in the presence of LiAlH₄. Or I can say butone will give you butol in the presence of LiAlH₄. Clear? Any questions, any doubts? Perfect. Now let's talk about the reduction of nitrobenzene. So you have this NO2, which is basically going to form this compound. This name is nitrobenzene, and this is phenylamine. Okay, so this reduction happens in the presence of, with the acid, you need hydrogen. In the presence of catalyst, let's say you add palladium to it, right? So that's a reduction of nitrobenzene. Clear? So that's all the reduction reactions, oxidation reactions, that's a part of it. Now, what else? Yeah, I also make notes if you can see it. No? No worries. Okay. BR2, what's the requirement or why you use BR2? What is a BR2 test? It's basically used for test of saturated and unsaturated compounds. So what happened? BR2 again is of orange reddish color. This we already done in IGCSE, right? So if you add a bromine water to any unsaturated compound, it will show an addition reaction because it will convert from reddish brown color or reddish orange color to colorless, right? And why it is happening? We did electrophilic addition reaction, right? In which the very first reaction we learned, we will in which we add bromine, remember? And what we were saying that when bromine is added, so both the carbons that were having the double bond attach bromine or chlorine to it. So when you are doing it with bromine water, that's the actual case basically happening. Reaction is happening. So the color changes from reddish brown or reddish orange to colorless, right? If you have not watched that, please go and watch that video for sure. Then the next type of question that can be there for, okay, not talk about alkanes. If you talk about alkanes or any homologous series, if you keep on increasing the chain, the melting point or the boiling point increases. Why? Because if you remember, we discussed inductive effect as well. Where we discussed this inductive effect? In the SN1, SN2 reaction mechanism, right? So in that particular reaction, we discussed about the stability of carbocation, where I told you about the inductive effect. So over there, when you are increasing with the alkyl chains, what is happening? You are adding more alkyl groups to it. Since more alkyl groups are being there and they have a nature of showing plus I effect, which is plus inductive effect. So the London dispersion force, which is added, which is present in our alkanes, get stronger because of that plus I effect. As a result, the melting and the boiling point is getting increased. Yes, that IUPAC thing I already told you, you need to be very strategic in while practicing the IUPAC naming, because it's very easy IUPAC naming that we are going to get it. And we will not exceed out the carbons with more than 6 carbons in a chain. So it will have a functional group and you have to use, that will be coming the part, like you have to use monochloride, dichloride. Please keep in mind when you write down like di or tri, so write down the number twice. If you are writing di, that means the something is coming 2 times. Please write it down that number. If it is 2,2, that even if the same functional group is coming in the same carbon or the same branch is coming at the same carbon, we have to write down that number twice, 2,2 or 1,2, whatever is the number coming, right? So please keep that. Students do 1 dimethyl. 1 di is not possible now. 1,1, not 1 actually. 2 dimethyl is not possible. 2,2 dimethyl is there. So if they are coming twice, we write down the number twice. Okay. Then if the question comes, alkanes are kinetically stable, thermodynamically unstable. What do you mean by that? Kinetically stable means we know that alkanes have a very strong bond, right? They are not able to break out easily since they are less reactive. Word kinetic means something which is in motion. So if we say alkanes are in motion, that means they are reactive, right? And alkanes are not reactive. So that becomes kinetically stable. Thermodynamic and stable, since because of the strong bond enthalpy, they require high amount of energy to break, which makes them kinetically unstable. So this could also be linked to entropy questions or Gibbs free energy questions, that the reactions that are spontaneous might be kinetically stable, thermodynamically unstable, or vice versa, right? So please check out that particular thing as well. We will be covering that as well. Okay. So that's all for today. I have to tell you all these small things. I have noted all this in this my notepad so that I don't miss out anything. I will be giving you one last on this when it comes to organic, in which we cover out the benzene, and then we will go to the pH curves. If you want me to give you the info for the spectroscopy, which include mass spectroscopy, IR spectroscopy, HNMR spectroscopy, so please let me know in the comment box or you can DM me as well, so that I can work it out with that as well for you. Okay. So stay tuned. I hope we have unlocked many things and this has given you a good clarity of what to do, what not to do. Still, you have any questions, any queries, you please text me as you are already doing, and I will for sure come up with the links in the upcoming video. Take care and have a good day. And don't forget to hit that subscribe button. Bye-bye.